and today we are talking about gravity and pressure fillers. So typical agenda here today, we'll talk a little bit about where to find these on Sigma's website. We'll define the type of equipment, talk a little bit about some benefits and features, talk about some favored manufacturers we like here at Sigma, how and where customers use this machine. I'll mention some upstream and downstream equipment to look at when buying and selling, industries used in, and then questions and key points when talking to clients and customers. So we'll just get into it. First and foremost, where to find on our website, you're going to find this under packaging equipment if you're looking to buy our equipment, the subcategory of filler, and then down to gravity and pressure filler. So that's where we're looking here. So category definition, there's some contention with the definition here. We'll talk a little bit about this a little bit later here, but basically, this equipment fills containers by releasing valves connected to a tank, allowing product to flow into a container. The idea is to allow gravity to do the work when filling containers. This category can be further defined into gravity or pressure filling. They are slightly different, but kind of serve the same function. Gravity fillers are going to be more suited for low viscosity liquids, oils, thinner products, things like that. Pressure fillers are going to make use of positive displacement pumps. They're going to be able to move a wider range of more viscous liquids. We're talking creams, gels, oils, or lotions, things like that. So upstream and downstream from a gravity and pressure filler. Upstream, you're going to see things like holding tanks to actually house the product, pumps, especially in the case of a pressure filler, mixing vessels if it needs any kind of agitation, bottle rinsers, depalletizers, accumulation tables. This is a short list. We'll get into more of kind of the options as we go forward here because there's a ton. Downstream equipment, you can look for things like cappers and retorquers, labelers, coders, more end of the line things like that, case packers, ring applicators, especially in the case of your 6-pack of plastic bottles, seamers if we're doing cans, palletizers, and of course, always stretch wrappers. So location in a production line. So before we get overwhelmed here, this shows a lot of different options. You're not going to see this complete setup in a lot of facilities, but we'll go through kind of what all this means. So in figures 1, 2, and 3 there, that is going to be before your actual filler. Figure 1 is going to be a depalletizer. So if your customer is actually bringing in their bottles from a supplier, then you're going to see some equipment like that. Now, if they want to get fancy and have a little more, consolidation here, they might be doing their own PET blow molding, which is going to be figures 2 and 3 there. So if they're doing their own bottles on site, you can look for something like that. Figure 4 there is going to be, the machine of the hour. That is going to be your filler. This specifically is a tri-block system. This is going to be not only your bottle rinser, but also your filler and your capper. So you've got a couple different options when it comes to how much complexity you want with your fillers. We'll look at some benefits and kind of drawbacks of that later. Moving on into figure 5 there, that's going to be some form of product inspection. A lot of times you're looking at fill level inspection to make sure the bottles are filmed uniformly. Moving on, if it fails inspection, you're going to see it's going to move over to an accumulation table. But if it passes, we're going to be coating it, sterilizing it, down to, figure 8 is going to be labeling. Number 9 in this case is going to be a shrink bundler variety, and then you've got over to palletizing. So again, you're not going to see both a depalletizer and a PET blower in a lot of facilities because they're usually doing one or the other, either bringing in their own bottles or making their own. But this just kind of gives you a sense of, hey, there's a ton of stuff to talk about whenever customers get into the filler question. So our first video here is going to be by Apex Filling Systems. This is a 4-head automatic gravity filler. So you see here, these are the actual fill nozzles. This has some operator involvement, so you're going to get some degree of automation here, but of course it's not going to be complete. What's really nice about a lot of gravity and pressure fillers is you're really only limited to the actual size of the nozzles and the size of the diameter of your container's opening. So in this video specifically, they're filling these larger jugs. If you had bottles or cans or cups or anything like that that were looking to be filled that these nozzles could fit into, there's no reason it couldn't fill them. Of course, the only limiting factors you're looking at there are going to be the kind of conveyor that it's going on and kind of upstream and downstream from there. But in reality, it's pretty basic. You're allowing gravity to fill a container. So why not fill the container if the nozzle can fit inside? Second video here, this is a similar variety. This is another inline, filling system. This is a 12-head filling system. We're doing smaller bottles in this case, and these bottles are actually being loaded into pucks by operators. This is a great option when you're dealing with these very small vessels like this because they're going to be very light, they're easy to knock over, it's going to be hard to keep them on the conveyor while also keeping them straight in line. And if you're doing a 12-head filler like this, they all have to be equally spaced. So the best way to do that, instead of using like a timing screw, you might have somebody loading them into pucks. So just something else to consider. Anytime you're talking fillers, the next question should definitely be, hey, what are we talking conveyor-wise? How are you getting your product underneath the nozzles? And then thirdly, I wanted to go through what a monoblock system would look like here. This is kind of your all-in-one variety. So what you're going to see here, you're going to see we have a timing screw that's actually equally spacing out of all of our containers to make sure they're properly fitting into the rotary here, similarly spaced. What's nice about this system is you're going to see these bottles go in. They're going to be continuously filled by the rotary system. And then after they're filled, you're also going to see they're being capped in the exact same machine. So this is nice when you're talking about higher speeds and greater efficiency. This is a full automation version of this line. And what's really nice is this can also save your customer in terms of if they have spatial requirements, dimension limitations, things like that. Because rather than have a complete inline system that may take up a long space, they can fit all of those machines inside of a small block. Now, there are some drawbacks to this. And like I said, we'll mention those a little bit later. But just to give you an idea of, you can go really big with this or you can keep it simple depending upon your customer's needs. So options to consider, gravity versus pressure. So a typical gravity filler without the pressurized system, it's your most economical option. This is your budget option, and you can kind of, get really variety with this, but it is limited. If you're only using gravity and there's no pressurized system to it, you're going to be limited to thinner liquids. If you're actually adding the positive displacement pump and making it a pressure filler, you're going to see an increase in price, but you've got a lot more applications. Things like, more viscous liquids, they're going to be difficult to, A, get out of the container you're storing them in, and B, to get them to come out of the nozzles into the container. So it's going to require a little extra oomph on that side. Something to consider when you're talking to your customers is viscosity. You'll hear the term poise, or maybe you won't, depending upon your customer's knowledge level, but this is the unit of measurement that you can kind of use to talk about the poise of a product, the viscosity of a product. For reference, ketchup and mustard is 70,000 centipoise, whereas peanut butter is 150,000. So it's a standardized unit of measurement, but a lot of times your customers may not know that. So the alternative is get a sample in. Get an idea of what product they're running so we can actually put it on the machines to make sure it's going to work for them. If it gets to a point where we're dealing with highly viscous liquids, heavy paste, things that aren't going to easily come out of the nozzles or things that are going to gunk up the system, that is when you're moving into the conversation of, okay, we need to look at piston filling. Piston filling is going to be your next standard up for highly viscous liquids. And there's a whole different conversation, and that's for another presentation. But just consider that when you're having that with your customer. Inline versus monoblock, like I said before, you're trading speed and efficiency for price. Your monoblock system is going to be, on the more expensive side, but you do have the benefit of efficiency as well as reduced footprint. And you're also going to see a greater replacement cost and downtime. So if you've got 3 different machines doing your rinsing, filling, and capping, one of them goes down, great, you only have to replace one machine. If a piece of that monoblock fails beyond repair, well, now you've also lost the other 2 or 1 piece, depending upon what you're doing. So you're talking about, speed and efficiency, but there's also greater risk if preventative maintenance isn't being kept up. So just consider that. Couple manufacturers here that we like. You're going to see Akasi, Accutech, and SureCap. Those are big ones for us. Industries using food and beverage, you're going to see this, chemical, industrial, pharmaceutical, cosmetics, even some confectionery. On the right there, I mean, like I said, you're the kind of the sky's the limit as far as what containers you're doing. The question of what kind of filler to provide for them is going to be based on speed, viscosity, and the only thing you need to consider is what conveyor to put with those machines. Couple category takeaways here, features and optional add-ons. Like I said before, inline versus monoblock. Filling style, just a note about this, there are different styles of filling. Overflow versus like bottom up. Bottom up filling is going to be great for customers that are doing, you know, product that foams up, bubbly product, things that are difficult to pour from a tall distance. The nice thing is with a bottom up filler, you're going to have those pistons actually go to the bottom of the bottle and then raise as they fill to prevent that, you know, overflow or anything like that. So especially if your customer is doing things like beer, carbonated product, anything that's going to foam, talk about bottom up filling. For the acquisitions team here, we're going to be looking at container size last ran, the last product that was run through it. This is extremely important, especially when we're talking about if a filler comes out of a chemical plant, we're putting it in something food grade. That's a difficult conversation to have. Output speeds that were achieved, even if they're running, you know, a 6 head, the size of the container and the fill rate are going to kind of decide the overall throughput. So talk to the customer, find out what they were running, what they were able to achieve. For sales, talk to your customers, get an idea of the viscosity of the product. If you guys are talking, they may have a really subjective, oh yeah, it's really thin, it's really easy to get through. Well, it might be for them, but compared to water, how viscous is it? So get a sample in, talk to them about, you know, limitations and things like that. Ask them about their desired output rate. You know, if they're requiring, you know, absolutely insane speeds, then yeah, you're going to be putting them into a monoblock or a tri-block. But if they need something inline and maybe they had a 2 head or a 4 head, maybe it's time just to move them over to a 6 or an 8. Just talk to them and find out exactly what they're trying to achieve and come to that conclusion that way. Also, other related needs. Like you saw in that previous integration slide, if they have a filler, there's 100 other machines that go around it. A lot of the fillers that we have already come with conveyors, but that isn't always the option. Sometimes different conveyors need to be changed out depending upon the size of the product. So talk to them and see what other machines need to go with this filler on this sale. For warehouse and logistics, monoblocks are bulky, but they've got some delicate instruments inside them. Make sure you're blocking and bracing them if they're running up against the walls. Even though it's a large, boxy machine, it's very easy to damage pieces of it. Inline systems, they can be top heavy depending upon how many heads and things like that, so make sure we're securing those. Engineering questions. Biggest thing to note on here, you're going to see a lot of the same stuff, but the actual nozzle dimensions are a huge factor to talk about because you may have the perfect nozzle size to get this kind of viscosity of product in, but if it's not going to fit in your customer's container, it doesn't help anybody. So talk to them, find out the diameter, find out, you know, what your kind of range for air is too, because obviously none of it's going to be a perfect exact science. So talk to them about what kind of diameters you're dealing with so we can figure out what size nozzles to put in there. Equipment listing example number 1, this is K9225. This is on order. This is a new Accu-Tech APOF6. This is a 6 head nozzle. Filling speed, you're looking at containers up to 60 per minute, and this is going to have a variable speed conveyor on it. Then this is a kind of a different version. I wanted to show this because I think we talk a lot about, you know, the high level versions of equipment, but what a mom and pop might be looking at. This is going to be an Akashi TruPump 1S. This is just a single head semi-auto pump filler. So this is very basic. It's mountable on a conveyor, doesn't actually currently come with one. It could be run tabletop if you just have an operator running it that way. Obviously, you run into the issue is if you need to put a lid on this hopper for, you know, USDA or food grade requirements, things like that. But if somebody's just doing, you know, hot sauce in their backyard somewhere, maybe the conversation about a 6 head automated filler isn't the right one to have. Maybe you start them here, and then as they grow and we grow with them, then we can move them into the new, you know, a monoblock or something larger than that. But kind of an entry level here, just to keep note of. So in summary, gravity and pressure fillers, they're highly versatile machines. The customization options, it's going to allow for a lot of different speeds, products, and additional add-ons. The goal is obviously to reduce deviation and variation, and this is a great way to do it when you talk about filling containers. The choice between these options is going to be the most important conversation to have when they bring us their needs as far as speeds, throughput, viscosity. There's a lot of nuance too when it comes to selling a filler and getting optimum speeds. So make sure you talk to your customer as much as possible about their requirements and their current products. Questions, comments, concerns?